5.4 today. So we are going to be finding unit rates. So we're going to figure out things like how much money per pound or how fast are they running per hour, things like that. So using that per word to find the unit rate, how much they can do at one time. A unit stands for one. So we want to take what we have and apply it to that same pattern to just one of those. And then we'll use that unit rate to solve other problems of how fast they could do it in a different amount of time using that same pattern. So we're going to start here and work on task 1. So make sure you have a paper and a pencil. You'll really want to be practicing these with me and practicing writing down the correct rate, because sometimes I really have to think about these. What is the problem asking me? And because you've got to set it up correctly. So we have Jack is at the supermarket. He finds a 5-pound bag of flour and a 2-pound bag of flour for the prices shown. So 5 pounds, so this is 5 pounds, this is 2 pounds. Which of the bags of flour is the better buy? So when we're talking about which is a better deal, that does not just mean which one is cheaper. Obviously, if you don't have enough money, like if you only have $2, you can't buy the $5 bag. You'd have to buy this one because it's cheaper. But that doesn't mean you're getting a better deal. When we're talking about a deal, we want to take it down to that unit rate. So the question that we're asking ourselves is we need to find the cost per pound. So every time you're buying a pound, how much does it cost? And that's what I always have to remind myself. Sometimes I have set these up incorrectly and I get done. I'm like, that just doesn't make sense. And so thinking about what are we finding? I want the cost per pound. That's telling me I'm dividing by the pounds, and pounds is going to be my second number. Or if I'm setting up a fraction rate, it will be the number on the bottom. So let's go ahead and set up these rates. So I'm dividing by the pounds. So if I have my cost here, I put that on top. So $2.69, and I'm going to divide that into 5 groups to see how much every pound costs. If you set it up backwards and I say I have 5 pounds and I'm dividing it by the money, you are going to get a completely different answer and it's not going to make sense. If I actually did this, the answer is $1.86. And if I'm buying 5 of those for $1.86, that's going to cost 1 times, this is almost 2, that's about $10 for the bag. And I know my bag only cost $2.69. So that does not make sense. So I've got to set it up correctly. So I know my money's going on top, pounds are going on the bottom, and then I'll solve that one there. And then let me erase this so I have a little more room right here. So now we need to set up our rate for the 2-pound bag. So go ahead and try and set that up and come back and match and see if we did it the same way. So I know I want my money on the top. So $1.89, and I'm cutting that into 2 groups to see how much each pound cost. So now we need to do the problem and set up that unit rate. So I'm trying to figure out how much 1 pound cost. I want to know how much 1 pound cost. So how do I get from 5 to 1? Well, I divided it by 5. And whatever I do to the denominator, I have to do to the numerator. So I'm going to divide the numerator by 5 and the denominator by 5. 5 divided by 5 is 1. So there's my 1 pound. So now I need to do $2.69, and I'm going to divide that by 5. So I want you to pause the video and see if you can come up with that answer. Remember, your decimal will go straight up, and then come back and check your work with me. So I know 5 can't go into 2, but it can go into 26 5 times, which is 25 and 1 left over. And it goes into 19. 4 is too big, so 3 times. 3 times 5 is 15. I have 4 left over, and I can't have a remainder when I have a decimal. A decimal is a remainder, so I can add another 0 because there's still 0 in that place and bring that down. And 5 goes into 40 exactly 8 times. So this answer is 0.538. But when we're talking about money, we usually only use 2 decimal places. So we're going to round it to the hundredths place. So if I underline that number and look back behind, that 8 is a big number. It is closer to the next place. So it makes the 3 go up. So we're saying our answer is 54 cents. Every time they buy a pound, they spent 54 cents. And that makes more sense. If I took 50 cents and times that by 5, that would be about $2.50, and the bag was $2.69. So pretty close to that estimate there. Where when we had the problem set up backwards, we were spending a lot more money than we needed to. Okay, so go ahead and try this problem here and see if you can see how much the $1.89 bag cost per pound. So I know to get from 2 to 1, I'm dividing by 2. And whatever I do to the bottom, we do to the top. So this cancels out. 2 divided by 2 is 1. So now we need to do our problem, $1.89, and I'm cutting it into 2 groups. So if you have not done this already, be sure to pause and try that. So I know 2 can't go into 1. I bring my decimal up, but it goes into 18 exactly 9 times. 2 times 9 is 18. That's 0, and bringing down my 9. 2 goes into 9 4 times, which is 8. 1 left over, but remember I can't have a remainder and a decimal. So I can add on zeros though after the decimal. 2 goes into 10 5 times, so 0.945. And then we'll want to round that to the dimes and the pennies. So underline the 4, look back behind. 5 is a big number that's going to push that 4 up. So this final answer is 0.95, so 95 cents, almost $1. If this is almost $1 and I have 2 pounds, $1, $2, that's very close to $1.89. That makes sense. So now I can look at this. So I know my 5-pound bag cost 54 cents every time I bought a pound. And my 2-pound bag cost 95 cents every time I bought a pound. So yes, if you buy a 2-pound bag, you will not spend as much money, but you're spending almost twice as much to get the same amount. So I'm saying that 54 cents is less. So I'm saying that it's a better deal to buy the 5-pound bag. If I wanted to buy 10 pounds of each of these, if I times 54 cents by 10, I would spend $5.40. And if I wanted to buy 10 pounds, but I only bought 2-pound bags, and I times this by 10, I would spend $9.50. And so if I bought 10 pounds, so this is 10 pounds, so I'd buy 2 bags of these. And if I bought 10 pounds, I'd have to buy 5 bags. I would spend only $5.40, but to get the same amount in the smaller bags, you're going to spend almost 2 times as much. So the better deal is the 5-pound bag. So let's go ahead and see if we can finish task 1 here. So remember, our money goes on the top because we're dividing by the pounds per pound. So our pounds are going to go on the bottom of these rates every time. So then tell me how you solved for the 5-pound bag and how we solved for the 2-pound bag and which one is a better deal. Now I want you to tell me why you think it is useful to be able to do this. When is this a helpful skill and how could it help you in real life? Let's go ahead and pause the video and come back when you're ready to do task 2. Okay, so task 2 is talking about Kendra ran 27 miles. Sorry, I read that very backwards. She ran for 27 minutes and she ran 3 miles. So first we need to figure out how can we find her rate per mile. So I want to see how long it took her to run every mile. So I'm going to circle these words here, per mile. That right there tells me what we are dividing by. So I want you to see if you can figure out how fast she ran every mile. So if I set this problem up and I put the 3 on the top and I divide by 27, that equals 1/9. And that would mean that she's running a mile in less than a minute. I don't know anybody that can do that. Even the fastest people, it takes them about 4 minutes to run a mile. So that just does not make sense. Always ask yourself, is my answer reasonable? And that was not. So if I come back here and read my problem, per mile, that right there tells me I should be dividing by the total miles. So it took her 27 minutes and she ran 3 miles. I want to see how long it took her to run 1 mile. So notice the miles match up and my minutes will match up. So to get from 3 to 1, we're dividing by 3. Whatever we do to the bottom, we do to the top. 27 divided by 3 is 9. 9 divided by 1 is 9. So every time she ran a mile, it took her 9 minutes per mile. So now I can use this information to answer some other questions. So how many miles can she run in 45 minutes? It took her 9 minutes to run 1 mile, and she now ran for 45 minutes, keeping that same pace. How many miles did she run? So I want you to see if you can figure that out using your strategy and then come back and see my strategy. So there's a couple ways that I can do this. So I know that I have 45 minutes and I want to divide that by the miles. And because I'm seeing how many miles, how many groups of miles. So I'm dividing by the miles. 45 divided by 9 is 5. So that is one way that I could answer this problem. So I'm going to talk about another way, a different strategy that we might want to be thinking about just for other problems that maybe don't work out so nicely. So I'm actually going to flip my problem around. And I know that she can run 1 mile and it takes her 9 minutes. Okay. Oh, sorry, this should not have said 45 minutes divided by 9 minutes is 5. Sorry, I did not. That was a bad label there. So I know in 1 mile, it takes her 9 minutes. And I'm trying to see how many she can do in 45 minutes. And so I'm going to multiply these and put this over 1. So my minutes are going to actually go away here. So 1 times 45 is 45. So since these are across from each other, they cancel out. And then 9 times 1 is 9. 45 divided by 9 is 5. So honestly, I like this strategy better. I know what I have. I know how many groups I'm trying to make. And so I can just divide. But sometimes our math just doesn't work out perfect, and you might have had 47 over 9. So this can be a helpful way to think about it. I know she ran 1 mile and it took her 9 minutes. And now I'm multiplying because I'm getting bigger to see how many more minutes. So these actually cancel out here. So when we're dividing, we want our labels to be across from each other. So this was miles, miles, miles. But when we're multiplying, you actually flip them so they're diagonal from each other so that they'll cancel out. But either way, we came up with an answer of 5. So now how many minutes would it take her to run 7 miles? So I'm looking for my minutes here. How many minutes to do 7 miles? So I'm going to put my minutes on top. So this is 9 minutes. And I know that is 1 mile. So I'm always using that basic ratio, that unit rate that we found here. 1 mile for 9 minutes. So she can run 1/9 of a mile in a minute, or 9 minutes per mile. That basic rate, either time, we have to set that up. And now I know that, didn't mean to put that equal sign. So I want to know 7 miles. And so I'm going to put 7 up here on the top and over 1. So my miles canceled out. So 9 times 7 is 63. 1 times 1 is 1. So I still have 63 minutes. 63 divided by 1 is 63. So it would take her 63 minutes to run 7 miles. I know she needs 9 miles per minute. 9 times 7 is 63. So just a couple ways to think about those same problems. For some of these problems, it is going to ask you to set them up like this. That's why I wanted to talk about that. If it does not make you use a certain strategy, then just use whichever way you like. If you know that the basic unit is 9 miles per minute and she did 45 minutes, we know we're dividing. This one, she was doing the same thing over and over again, and it wanted to know how many minutes. Well, I know it's going to take her longer than 9 minutes to run 7 miles, so we know we needed to multiply here. So you can decide which strategy you like, but do know this is what we're doing is we're setting up these rates and these ratios to say the same thing is happening over and over again. We could also make a table, and I could say this is how many miles, this is how many minutes. And I know it takes her for 1 mile. I don't know why my pen is not working all of a sudden. We're back in business here. So I know in 1 mile, it takes her 9 minutes. So that means 2 miles would be 18 minutes. 3 miles is 27. 4 miles is 36. 5 miles is 45, which is what we found up here. We said in 45 minutes, she could run 5 miles. 1 to 2 is times by 2. 9 times 2 is 18. 1 times 3 is 3. 9 times 3 is 27. We just keep following these same patterns every time. And as long as you're using those same patterns and using that basic unit rate of 1 mile for 9 minutes, then you're going to find your answers as long as you're using that same pattern. So lots of strategies to come up with the same answer. So let's go ahead and I don't know how to make. Okay, so let's go ahead and answer task 2 here. So we need to figure out how to do Kendra's rate per mile. And then, so when I first write that rate of 27 minutes for 3 miles, this is not a unit rate because the number on the bottom is not a 1. So you're going to tell me, what would you do to figure out that 1 mile? How long can she run? How many miles in 45 minutes, which we practiced? How many minutes to do 7 miles, which we practiced? And then tell me which of these statements are correct. And then tell me how you would find an equivalent rate. So let's say we know she ran 9 minutes for each mile. So if you were wanting to tell me how long it took her to run 2 miles or 3 miles or 4 miles, what would you do for each of those? Okay, then go ahead and pause and come back when you're ready to do task 3. So task 3 here, we have a potter is making clay pitchers. And to do 12 pitchers, it took him 7.5 hours. So let's come over here. So we know 7.5 hours to do 12 clay pitchers. So we want to know how many pitchers he can make per hour. So how long did it take him, or how many could he do every hour? So our rate that we're finding is, we know he can do 12 pitchers. So I'm just going to put a P for pitchers. And it took him 7.5 hours. I want to know how many pitchers he can do each hour. Every time there's 1 hour, how many did he complete? So to get from 7.5 to 1, we're dividing by 7.5. So I need to take 12 and divide it by 7.5. So I have 12 and we're dividing it by 7.5. So remember, we need to move our decimal, which means the decimal on the 12 is at the end. We're moving our decimal. So we have 120 divided by 75. So go ahead and see if you can do that problem and then come back and check. So I'm going to make a list of 75s. 75 more is 150. 50 more is 200. 25 more is 225. So I'm going to use that to get me started here. So I know it can't go into 1 and it can't go into 12, but it can go into 120 one time. 1 times 75 is 75. So I need to borrow here. So 10 minus 5 is 5. 11 minus 7 is 4. And I can't have, when I have decimals, that means I should give my answer as decimals here. So we're going to add another 0. It doesn't change the problem because it's after the decimal, and bring this down. So I need to keep on going. So 75 more is 300. 375. Oops, I forgot my 7 in there. 375. 25 more is 400. 50 more is 450. So it can go in there 1, 2, 3, 4, 5, 6 times 1.6. So it went in there exactly. So there's nothing left over. So every time she spent an hour, she makes 1.6. So about 1.5 pitchers every hour, which makes sense because if I do 7.5 times 1.6, the answer will be about 12. So I know she's doing a little bit more than 1 per hour. She can't do 2 because I know 2 times 7 is 14 and she doesn't make 14. So it's got to be less than 2, more than 1, 1.6. every hour. So now we're going to use that information to answer some other questions. So how many pictures are made in 70 hours? So I know that it took her she can do 1.6 pictures every hour. And I want to know, when there's 70 hours, how can we know how many pictures there are? So to get from 1 to 70, I have to times by 70. Whatever I do to the top, I have to do to the bottom. So 1.6 times 70 will tell me how many she could make in 70 hours. So notice my hours are on the bottom and those match up. So now I need to do 70 times 1.6, or you could do 1.6 times 70, either way. So go ahead and pause and do that. So 0 times 6 is 0. There's 42. Placeholder, 1 times 0 is 0, and a 7. So we've got, kind of running out of room here, 0, 2, and 11 with 1 decimal place. Move over 1. So she can make 112 pictures if she works for 70 hours. So setting up these proportions and saying my hours match up, my pictures match up, but we're using that basic rate, we can find any numbers here. I could see how many pictures she made in 350 hours, or I could say, like, after she made this many pictures, how many hours did it take? We can use our unit rate to find any answer using this information. So our next question asks us, if we want to find how many hours it took to make 60 pictures, we can set up the same problem here. So I know it takes 1.6 pictures for every hour. And this time I'm looking for my hours. So I don't know how many hours, X amount of hours, and we need to get to 60 here. So I've got to figure out, how did we get from 1.6 to 60? 1.6 times what is going to be 60? Now, I don't know that off the top of my head. That's not a very nice number, like 1 times 70 is 70, or 2 times 5 is 10. That's not just something I know. So I'm looking for something that times the pictures. 1.6 times P equals 60. So I can go and do the opposite of times, which is divide, and I can do 60 divided by 1.6 to see what we're timesing by, and then do the same thing to the bottom. So I need to move my decimal, which means move my decimal on 60, turns it into 600. So I'm really doing 600 divided by 16. I know it can't go into 6. Let me make a list here. So 16 plus 16 is 32. And I've got to go bigger. So another 16 here makes that 8 and 48. Let's do one more and see what happens. There's 16 more. It's 4, 4, 5, 6, 64. So that's too big. So I know I can go into there 1, 2, 3 times. So get my decimal after that 0 there. So 3 times 16 was 48. Left over is 12. And bringing down my 0. So I'm at 16. I've got to 64. So let's keep on going here. So 16 more. There's 10, 80. So 80, 6 more is 90. 16 more is 96. So then 96 plus 16, and then 2, 9, 10, 11. At 112, if I do 16 more, I believe that will be too big. So 128, yep, too big here. So it goes into 120, 1, 2, 3, 4, 5, 6, 7 times. So 37 7 times 16 was 112. 120 minus 112 is 8. And then I'm bringing down a 0 after the decimal, doesn't change it. And it goes into there, 1, 2, 3, 4, 5 perfect times. I covered up my decimal there. So to make 60 pictures, it would take 37.5 hours. So you're just figuring out, how did I get from here to here? Well, I know my answer got bigger, so I had to multiply. I don't know what 1.6 times something to equal 60. So we had to do a little bit, we had to do the opposite and divide. So 1.6 times 37.5 is 60. So now I do the same thing. 1 times 37.5 is 37.5. So that one was a lot easier on the bottom. So we're just doing that same thing. So I want to show you one other way you can think about these problems. So I know I'm going to match up my pictures, and I wanted to know how many hours it took for 60 pictures. So notice my pictures are matched up, and I know it takes 1 hour to do 1.6 pictures. And I was looking for how many hours. I don't know this number. So we have these proportions set up. So you can actually set up this proportion, and I can do 60 times 1 is 60. And then you take this other number here. So we've matched up our diagonal across, and you times those. 1 times 60 is 60. And then you take the other number you have and you divide by that. 60 divided by 1.6. That's exactly what we did up here. 60 divided by 1.6. So you can either just ask yourself, how do I get from here to here? You might have to figure it out and do the opposite and then do the same thing to the bottom. Or you can set up this proportion and say, I'm going to multiply these and divide by this. So let's just think about one other problem here and practice a couple of those strategies. So let's say that we have 12 servings of soup, and we need 8 cups of chicken broth. So 12 servings of soup, and we need 8 cups of chicken broth. So I want to know how much I need if I'm making 30 servings. So how much for 30 servings? Let's try this out. So I can set up this rate. So I know I have 12 servings needs 8 cups. So I'm going to make sure anytime I'm talking about servings that I'm going to put that on the top. And anytime I'm talking about the cups of chicken broth, that's going to go on the bottom. So 12 and 8. So how much for 30 servings? Well, I'm talking about servings, so I know this needs to go on the top here. And I'm looking for how many cups. So I could ask myself, how did I get from 12 to 30? There's not a nice whole number that makes that. 12 times 1 is 12, times 2 is 24, times 3 is 36. There's not a nice whole number. So I can think of this in a different way. So I can either ask myself, 12 times what is 30? And I can take 30 and divide it by 12. 12 can't go into 3. It can go into 30 2 times, which is 24. 6 left over. I can add this 0 here and put that decimal there. Same problem. 12 goes into 65 times. So I know that it takes 2.5 times the recipe to get to 30 servings. Now I can just do the same thing to the bottom here and do 2.5 times 8 is 40. There's 16, 17, 18, 19, 20 with one decimal place equals 20. So every time they need 30 servings, that means they need 20 cups of chicken broth. So that's one way you can just ask yourself, how did I get from here to here? Do the same thing. Another way, and I think it's a little quicker, is if you set up your proportion here. I need 12 servings with 8 cups of chicken broth. Now, if I want 30 servings, so notice the servings are matched up, then I'm asking myself how many cups. So we can use a little trick here, and we're doing the same thing. It's just taking a little shortcut. We're using this proportion strategy. So I can cross multiply here. 30 times 8 is 0, 24 is 240. And then I'm taking this other number here and I'm going to divide. So all I'm doing is I'm rearranging this problem and setting up a different proportion, but we're going to get the same answer. So if I take 240 and I divide it by 12, 12 can't go into 2, but it can go into 24 2 times, which is 24. Bring down my 0. 12 goes into 0. 0 times, I came up with this answer right here is 20. So I was doing the opposite of 30 divided by something. So I had to multiply and bring it to the other side. And then we had to do the then we had to divide by 12. So really, you're doing the same problem and you're going to get the same answer. It's just different ways and strategies. So you can pick which way you like to solve these problems. This is my preferred way, is to just think, okay, I know I need to do 30 times 8 and then divide it by 12. And it won't matter what the numbers are, just match them up across, divide by the other number that's still there. Will tell you the one you're missing. So look, we said 20 cups, 20 cups. So this one, we just found the unit here. And this one, we rearranged the problem, but we're getting the same answer. Okay, so let's go ahead and look at task 3 here. So I know this is kind of a long lesson, but there's a lot of information and it's stuff you're going to use, and you need to know how to find a unit rate so that you can make sure you're saving yourself money when you're at the store, getting the best deals, that you're not getting ripped off and things like that. So remember, pitchers divided by hours because we want to know per hour. And then that's not a unit rate because this is not a 1 on the bottom. We need to always make that second number equal to 1 is how you find a unit rate. So tell me how we found that, how we could find 70, and then how we would find how many hours it took to do 60. Okay, so tomorrow there'll be some more practice that I will do with you to help set you up for your homework. So if you are still having a hard time, be sure to watch the video tomorrow where we're going to practice some more problems to help you with your homework. Hey, let me know if there's anything I can do to help you.